All right, today we're going to look at some problems from section 4.6. Again, we're applying the rational root theorem to completely factor, and then the fundamental theorem of algebra, where we're writing our polynomial as a product of what we would call n, which is our degree, linear factors. Okay, so with our first problem, we're going to look at the rational root theorem, and so our constant term is 1. Factors are just plus or minus 1. The leading coefficient is 1. Our constant term is 6. Factors are plus or minus 1, 2, 3, and 6. So not too many when we look at all of our possible rational roots, each of the integer factors of the constant term divided by the integer factors of the leading coefficient. And we'll start by trying 1. So I have 1, 1, -5, -3, and 6. So bring down the 1, multiply and add, multiply and add, multiply and add, multiply and add. And sure enough, 1 is a factor, or 1 is a root rather. So x minus 1 is a factor. So again, I'm looking here and I think I can factor this. So if I set f of x to be x minus 1, and then we here have x to the third plus 2x squared minus 3x minus 6. If I factor a -3 out of there, I have x plus 2. So if I factor an x squared, I'm also left with x plus 2. And so now I see that I have x minus 1, factor out an x plus 2, and notice I'm left with x squared minus 3. So I see that I'm going to have some irrational roots. If I take x squared minus 3, set it equal to 0, we get 3, absolute value of x. So x equals plus or minus root 3. So there's 2 of our roots. And in applying the fundamental theorem of algebra, I can write this as a product of n, which is 4, because our degree is 4, linear factors. So x minus root 3 and negative root 3. And so our roots over here are also at 1 and at -2. Okay, so now here again, rational root theorem, leading coefficient is 1, constant term is 18. So we have 1, 2, 3, 6, 9, and 18. So, yeah, we've got a lot of things, a lot of possible rational roots here for us to consider. So let's start with 1. Let's see where that takes us. So we have a 1, 1, 0, 0, 7, 7, -2. And so I see, well, 1 doesn't work. And so this is at the point in time where what we want you to do since you're doing this for homework, is with your graphing calculators, is let's put this into our graphing calculator. That's an old graph. Let me clear that out. I actually have an x to the 4th. I've got a little bit of this, so I'm going to use, I'll just clear it out. Okay, so we have x raised to the 4th minus x raised to the 3rd plus 7x squared minus 9x minus 18. And look at my graph. Okay, so I'm certainly not seeing all the roots, but what I do see is I have one at -2, or -1 rather, and one at +2. Alrighty, so I'm going to just change that, and I'm going to go back. I'm going to use, because I'm kind of running out of a little space here, right? So I'm going to use -1, 1, -1, -2, 2, 9, -9, -18, -1 times -18, 18, and 0. So again, I see that I can factor this, but I'm going to use what I saw here, and I see that 2 is a root. So just to mix it up and show you a different way to look at this, so I'm going to bring down the 1, 2, that's 0. So 2 times 0 is 0, 9, 18, 0. Okay, so what does that leave me with here? So my function is x minus -1 or x plus 1, x minus 2. And now I have x squared, right, because that's a fourth, so a third, then a second degree, plus 9. So over here, looking at our roots, we have x equals -1, x equals 2. And if I take x squared plus 9, set it equal to 0, subtract 9, we get -9. Square root, there's our absolute value. See, there's a negative, so that's going to be an imaginary number. That's 3i. So plus or minus 3i. There's our 4 roots, right? 1, 2, 3, 4. And then applying our fundamental theorem of algebra, writing this as a product of n linear factors, x minus 3i and x plus 3i. So we've got some irrational real roots, and then we also have some imaginary roots. Okay, let's look at a couple more scenarios. So here, again, our rational root theorem. Leading coefficient is 1, constant term is -2. So nice and easy, plus or minus 1, plus or minus 2. So again, I'll try 1, -2, 1, 2. So 1, 1. -1, -1, 0. That's a 2. I'm sorry, that's a 0, right? 1 times 0. That's a 2. 1 times 2 is 2. That's a 0. Okay, so we have one of our roots. So the other one could be 1 again. It could be -1. It could be plus or minus 2. I'm going to try -1. Let's see, 1, that's -1, add, and we get -2. -1 times -2 is positive 2. 0 plus 2 is 2. Multiply, we get -2, 0, and sure enough, 1 and -1, and there's our quotient. So now I see that I have x minus 1, x plus 1, and again, going down from a fourth to a third to a second degree, minus 2x plus 2. Okay, so I look at this and I know that's not going to factor. So I want to find the roots. So I know I have plus or minus 1. And so I'm going to take this factor, x squared minus 2x plus 2, and set it equal to 0. Good candidate for completing the square. Our b term is even. Leading coefficient is 1, so I'm going to subtract 2. Half of -2 is -1. Square it. We're going to add 1 to both sides. X minus 1 squared equals -1. Take the square root. Here's our absolute value. Square root of -1 is I. And so we end up with 1 plus or minus I. So again, we end up with imaginary roots. So in writing that up here, applying the fundamental theorem, we have x minus one of our roots, which is 1 plus I, and then the other one is 1 minus I. So there's our fundamental theorem of algebra, writing it as a product of n linear factors. Okay, last one. Write a polynomial with, should be the least degree polynomial. Let's just put that in there, a least degree, because we don't know if any of these are double roots or triple roots, so we're just going to say that they are single roots, leading coefficient of 1. So f of x equals, so if I have 0 as a root, x is the factor. Then we have x minus -2, which is x plus 2. And again, because we have both imaginary and we also have irrational, both of these come in pairs. So if we have I, we have to have -I, and if we have root 2, we have to have -root 2. So that means we have x minus I, x plus I, x minus root 2, and x plus root 2. So again, here's the fundamental theorem of algebra. Normally we would multiply those, so we'd have, that would leave us with x squared plus 1, and when we multiply these two, and here we'd be left with x squared minus 2. So 1, 2, 3, 4, 5, 6, 2, 4, 5, 6. there's our polynomial. Hope that helps, and we'll see you soon.